I am Ramakrishna B N, content developer, digital learning, Department of Collegiate Education. So I'm going. So I will. I will. I am going to discuss about stellar characteristics for BSc fifth sem students. So in astronomy and astrophysics paper. See in stellar characteristics unit. So in this session we are going to understand the protostars, pre-main sequence stars, main sequence stars. The learning objectives are concept of protostars, main sequence stars, and and pre-main sequence stars. So students must be able to understand the protostars, pre-main sequence stars, and main sequence stars. So now first of all we will understand what are protostars. A protostar is a very young star that is still gathering mass from its patent molecular cloud. The protostellar phase, is the earliest one in the process of stellar evolution. For a low mass star, it lasts about 5 lakhs years. The phase begins when a molecular cloud fragment first collapses under the force of self gravity and an opaque pressure supported core forms inside the collapsing fragment. It ends when the infalling gas is depleted, leaving a pre main sequence star at the onset of hydrogen fusion producing helium. So now we will understand about the formation of protostars. How protostar forms? A protostar is formed as gravity begins to pull the gases together into a ball. This process is known as accretion. As gravity pulls the gases closer to the center of the ball, gravitational energy begins to heat them, causing the gases to emit radiation. At first, the radiation simply escapes into space. Now, we will understand about the pre-main sequence stars. See, the pre-main sequence star is a star in the stage when it has not yet reached the main sequence. Earlier in its life, the object is a protostar that grows by acquiring mass from its surrounding envelope of interstellar dust and gas. After the protostar blows away this envelope, it is optically visible and appears on the stellar birth line in its HR diagram. At this point, the star has acquired nearly all of its mass but has not yet started hydrogen burning, that is nuclear fusion if hydrogen. Now we will understand about the pre-main sequence stars. The star then contracts its internal temperature, rising until it begins hydrogen burning on the zero age main sequence. This period of contraction is the pre-main sequence stage. When mass accretion stops, the protostar is called a pre-main sequence star. A pre-main sequence star contracts slowly, unlike the rapid collapse of a protostar. When the temperature in the core reaches 10 million degrees Kelvin, hydrogen fusion begins. Now we'll discuss about what are what are main sequence stars. In astronomy, the main sequence is a continuous and distinctive band of stars that appears on plots of stellar color versus brightness. These color magnitude plots are known as HR diagram. Stars on this band of HR diagram are known as main sequence stars or dwarf stars. These are the most numerous true stars in the universe and include the Earth's Sun. The main sequence stars, also called dwarf stars, are stars that fuse hydrogen in their cores. These are dwarfs in that they are smaller than giant stars, but are not necessarily less luminous. Example for main sequence stars are a blue O-type dwarf star is brighter than most red giants. Main sequence stars belong to luminosity class 5. There are also other objects called dwarfs known as white dwarfs. These are not main sequence stars but stellar remnants. Unlike true stars, brown dwarfs have too little mass to sustain nuclear fusion, so they do not belong to this category either. The border between the lowest mass main sequence stars and brown dwarfs is somewhat ambiguous. Subcategories of main sequence stars are: this category has the following 8 subcategories: A type, B type, F type, G type, K type, M type, O type. So these are the main sequence stars, subcategories of main sequence stars. The references are shown here. Thank you.